Hello everyone. Today we are going to read lesson 4 Major Landforms. We have studied in the previous chapter that the earth is a dynamic place, that is, it constantly undergoes changes as the endogenic forces form various landforms on the earth's surface. The exogenic forces in turn work to reduce the elevation of the existing landforms. The exogenic forces work in two ways: weathering and erosion. Weathering is the process of breaking rocks into soil, sand, and other tiny pieces called sediment. Weathering can be caused by water. Some of the minerals in rocks dissolve in water. Water can also seep into cracks in the rock and freeze. When it freezes, it expands and breaks the rock apart. Wind can also cause weathering. Wind that contains sand wears rock away and creates tiny rock pieces. Plants can also cause weathering. The roots of plants can spread inside cracks in a rock. This loosens the rock and pushes pieces of rock apart. Bits of rock soon break off. In addition to these factors, some other agents like heat, cold, frost, animals, and chemical reactions also contribute to weathering. Weathering does not include movement of sediment. Weathering can take millions of years to become markedly visible. For example, the Grand Canyon was carved out of the Colorado River, but it took about 6 million years. Erosion is the process by which sediment is moved from one place to another. Sediment is tiny pieces of rock, soil, and sand. Erosion carries weathered materials away from a place. Agents of erosion include flowing water, waves, wind, ice, and gravity. Eroded material is eventually dropped somewhere else. This is called deposition. Gravity causes landslides and mudslides, whereby huge chunks of earth move to a new location. Thus, varying landforms are created by agents of weathering, erosion, and deposition. Work of rivers. A river is fresh water flowing across the surface of the land, usually to the sea. River flows in channels. The bottom of the channel is called the bed and sides of the channel are called the banks. Rivers begin at their source on a higher ground such as mountains or hills, where rainwater or melting snow collects and forms tiny streams. When one stream meets another and they merge together, the smaller stream is known as a tributary. It takes many tributary streams to form a river. A river grows larger as it collects water from more tributaries along its course. The great majority of rivers eventually flow in a larger body of water like an ocean, sea, or large lake. The end of the river is called the mouth. The area drained by the river and its tributaries is called the river basin. The running water in the river performs three functions. It erodes the rocks, It transports the eroded materials. It deposits the transported materials. The erosional action of the river results in the widening and deepening of the river valley. Such a valley is called a V-shaped valley. Waterfalls often form in the upper stages of a river where it flows over different bands of rock. It erodes soft rock more quickly than hard rock, and this may lead to the creation of a waterfall. Waterfalls are formed in several ways. For example, a river may plunge over the edge of a plateau, or it may fall almost vertically down a steep valley face. This steep, swift flowing segment of the river is called a rapid. It is common for waterfalls to form where a river crosses a band of hard rock or resistant rock. In its initial journey across a hilly terrain, the river flows very swiftly and thus more erosion occurs with practically negligible deposition. As the waterfall retreats upstream, it leaves behind a narrow, steep-sided feature known as a gorge. Gorges can also be formed in other ways. The Grand Canyon of the Colorado River in the USA formed as the surrounding land was uplifted. Nokkalikai Falls in Cherrapunji, Meghalaya is the highest plunge waterfall in India with a height of 340 meters. Garsopa Falls or Jog Falls on the Sharavati River in Karnataka is another very high waterfall in India, about 260 meters. Other famous waterfalls in the world are the Niagara Falls, North America, and Victoria Falls, Africa. Angel Falls, Venezuela, South America is the highest in the world at 979 meters. As the river enters the plain, it flows less swiftly and the river floor widens due to continuous erosion along its banks. Now the river twists and turns, forming large bands or loops called meanders. A meander is a bend in a river. The curves are called meanders because they slowly wander over the land. The river carves out S-shaped bands. The formation of meanders is due to both deposition and erosion. The meanders gradually migrate downstream. If the meander moves so much that the bend becomes very large, the course of the river may change. The meander may be cut off by a straighter flow of the river and deposition fills the section that no longer flows. This forms an oxbow lake. In arid regions, a mountain stream may flow onto flatter land. The stream comes to a stop rapidly. The deposits form an alluvial fan. Example, an alluvial fan in Death Valley, California and Nile River Delta in Egypt. Deposition also occurs when a stream or river empties into a large body of still water. In this case, a delta forms. A delta is shaped like a triangle. It spreads out into the body of water. The delta found by the Ganga and the Brahmaputra rivers is the largest delta in the world. A flood occurs when a river overflows its banks. This might happen because of heavy rains. The fine alluvial soil is brought by the river on the valley floor. This fertile part is called floodplain. As the water spreads out over the land, it slows down and drops its sediments. If a river floods often, the floodplain develops a thick layer of rich soil because of all the deposits. That's why floodplains are usually good places for growing crops. For example, Nile River in Egypt provides both water and thick sediments for raising crops in the middle of a sandy desert. In the floodplain, coarse materials are deposited along the banks of the river. Thus, long ridges of low height are formed along the banks. These are called natural levees. Work of sea waves. Have you ever stood on a sandy beach and let the waves wash over your feet? If you have, then you probably felt the sand being washed out from under your feet by the outgoing waves. This is an example of wave erosion. Runoffs, streams and rivers carry sediments to the oceans. The sediment in ocean water acts like sandpaper. Over time, it erodes the shore. The bigger the waves are, the more sediment that they carry and the more erosion they cause. Seawater is aided in its eroding action by tides, storms, and currents. Marine erosion and deposition is confined to a narrow belt along the coast. This gives rise to various coastal landforms. Wave-cut cliffs form when waves erode a rocky shoreline. They create a vertical wall of exposed rock layers. They are also known as steep rocky coast. Sea arches form when waves erode both sides of a cliff which projects into the sea. They create a hole in the cliff. They are also called roof of the cave. Sea stacks form when waves erode the top of a sea arch. This leaves behind pillars of rock. They are also known as walls of the cave. A beach is a narrow strip of land that lies along the edge of an ocean, lake or river. Materials such as sand, pebbles, rocks, and seashell fragments cover beaches. Beaches are usually formed when the sea is calm and winds are of low velocity. Waves may also deposit sediments to form sandbars, offshore bars, and barrier islands. Sometimes the sea water is trapped behind the sandbar. The partially enclosed saltwater lake thus formed is called a lagoon. Work of moving ice. A snowfield or neve is an accumulation of permanent snow and ice typically found above the snow line, normally in mountainous and glacial terrain. Glaciers originate in snowfields. Large masses of ice formed over many years that do not melt during the summer are called glaciers. They move slowly over an area of land such as a mountain valley. Glaciers exist in high mountains throughout the temperate zones and cover most of Antarctica. Glaciers too are agents of erosion, transportation, and deposition. Pure ice by itself cannot cause weathering, but the rocks falling into them from mountain slopes and the rocks carried along from the valley floor act as tools of erosion. These rocks rub against the sides and floor of the valley, creating a U-shaped valley. The landforms created by glacial erosion are cirque or corrie. The glacier carves out deep hollows along the slope of the mountain. This develops into an armchair-shaped depression called cirque. When glacial ice melts, this depression fills with water, forming a lake called tarn. Layers of snow formed in the process of compaction and recrystallization are called firn. U-shaped valley. The glacier does not carve a new valley like a river, but deepens and widens a pre-existing valley by smoothing away the irregularities. In this process, the glacier broadens the sides of the valley. The shape of the valley formed in this manner resembles the letter U. It is therefore called a U-shaped valley. Such a valley is relatively straight, has a flat floor and nearly vertical sides. When the glacier melts or retreats, it deposits its load on the sides and floor of the valley. The debris thus deposited is called a moraine. Work of wind. Wind action moves mineral particles when they are in a dry state and unprotected by vegetation cover. These conditions are found in deserts and semi-arid regions of the world as well as on sandy shorelines. Landforms made by wind erosion are mushroom rocks or rock pedestals. When rocks consisting of alternate hard and soft layers are subjected to wind abrasion, it results in differential erosion. The soft layers are easily eroded, but the hard layers resist erosion. As a result of undercutting near the base, the resulting feature resembles a rock pillar shaped like a mushroom. It is aptly called rock pedestal or mushroom rock. Also, wind cannot lift rock particles high up in the air and closer to the ground. Its erosive power reduces due to ground friction. The ideal height at which wind erodes the most is about 25 cm to 75 cm above ground, and thus it erodes the lower part of the rock more than its upper part. This results in mushroom rocks being formed. Such formations are common in the Sahara Desert and are also seen near Jodhpur. Landforms produced by wind deposition are loess and sand dunes. Loess. In several large areas of the world, the surface is covered by deposits of wind-transported silt that has settled down from dust storms over many thousands of years. This material is known as loess. It is also very easily eroded by running water. The thickest and greatest deposits of loess are found in northeast China. Sand dunes. When the wind blows, it lifts and transports sand from one place to another. When it stops blowing, the sand falls and gets deposited in low hill-like structures called sand dunes. As long as the wind is strong enough to carry the sand dunes are mobile and they keep on shifting from one place to another. If vegetation or a line of trees starts growing on the dunes, they become fixed. They also become stationary when they are blocked by a hillock. In case there is no such obstructions, sand dunes may bury agricultural land, plains, and settlements. This was the reading of our lesson 4, Major Landforms. If you have any doubt or query, you can ask me in the comment section below. Also, you can find the links to other lessons in the description box below. Thank you everyone.